Welcome back to my continuing series on fractions. Fractions, part 3! I know what you're thinking. I said I'd jazz this outfit up a little bit for this one, so... Not enough. No, I agree. Let's go all the way. Yeah, there we go. Feeling some 90s Britney Spears action here. Let's move on. Aside last time that we talked about simplifying, and that is just what we're going to do. We're going to simplify some fractions. So, let's start with something really complex and difficult, and let's make it easy. I'm not going to lie, 12 and 18 are two of my favorite numbers, and the reason for that is because they're divisible by so much stuff. I love divisibility. I like primes, don't get me wrong. I'm a number theorist, so primes are my bread and butter. But I love divisibility. I think it's so cool that 12 is divisible by like half of the stuff that's less than it, right? I mean, not really, but almost. 12 is divisible by 1 and 2 and 3 and 4 and 6, and it's so cool. Alright, but let's stop gushing about 12. That's not what we came here to talk about. We came here to talk about simplifying fractions. So, we have something that's divisible by a lot of stuff. 12. We have something else that's divisible by a lot of stuff. 18 is divisible by 1 and 2 and 3 and, not 4, and 6 and 9. And there's a lot of stuff on those lists that overlap. Alright? So what you may have been told to do in school is to write a list of all the things that they're divisible by. Okay, let's do it. Boring, but we'll do it. 1 and 2 and 3 and 4 and 6 and 18's got 1 and 2 and 3 and 6 and 9. And then what you're supposed to do is you're supposed to look for the biggest number on both lists, 6, and this is known as the greatest common factor. Okay, that's actually a useful thing that comes up in math. Maybe not in real life, it might not be that useful, but for me, a math nerd, it's a pretty cool thing, being able to find greatest common factors, and there's a super cool trick to it called Euclid's algorithm, and maybe I'll show you that sometime if you play your cards right. But what we want to do from here is divide by 6 and 9, so I'll do 12 divided by 6, 18 divided by 6, and that'll give you 2 over 3. Okay, that works. I'm not saying that that's not the right way to do it. I'm just saying that it doesn't help you think about what's going on. What helps you think about what's going on? What have we learned in the last 2 videos helps you think about what's going on? Kick. Cake! Alright, I'm going to cut into 12 slices. This isn't going to be pretty. Bear with me. Alright. I'm even going to use this divisibility to do it. So, 12 is divisible by 4, so I can start by dividing it into 4 pieces. Then, since 12 is 3 times 4, I can divide it like that. Alright. I can do the same thing for 18. I can do it. It's going to be a lot of slices, but I can do it. 18, not divisible by 4. Divisible by 2, though. So I'll start with that. I like these even numbers because I can draw straight lines. Alright, then that's 2 times 9. I'm going to divide that 9 up into 3 and 3. So I'll divide each of these into 3. So now I have it divided into 6. And now I'm going to divide each slice again into 3 to turn 6 into 18. Because that's how numbers work. Don't tell anyone I have a degree in art. Alright, like I said, it's not beautiful, but there's a wagon wheel. Okay, we have 12 of these babies. 12 tiny little slices of cake. And I'm gonna eat them. Cakes fear me. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 slices of cake. Okay? And now, the magical thing that I have at my disposal is cake glue. I'm going to use this cake glue to start gluing things together to make bigger pieces of cake. Because I don't like an 1/18 of a cake. I want bigger pieces. I'm going to take these 2 chunks and I'm going to glue them together with my cake glue into one piece. Then I'm going to take these 2 and glue them together. Okay. Cake glue all over the place. I'm also going to glue together the pieces that I didn't eat. Okay. So there's one. There's one. And there's one. So now in this absolutely hideous picture, what we can see is instead of having 18 pieces of cake, since I glued every pair together, I have 9. So I have 1, 2, 3, 4, 5, 6 that I've eaten, and 1, 2, 3 that I have not eaten of these 9 pieces. So I've got 6 over 9 slices of cake. Okay? I can do this again. I've got 3 pieces here, 3 pieces here, 3 pieces here. Let's cake glue it up so these 3 can become 1. These 3 can become 1. And these 3 can become 1. So I've eaten 2 slices out of 3 total slices. When you simplify a fraction, when you divide the top and bottom, what you're doing is you're gluing things together. You're putting pieces back together. If you have 5 halves of an egg, it's like 5 deviled eggs, right? You can't really glue those pieces back together. But in math, anything's possible. In math, we have glue that can put 2 deviled eggs back together into an egg. You can take 2 halves and make a whole. You can take the bottom half of the fish and the top half of the person and make a mermaid. You can take 2 halves of anything and squeeze them together and make a whole of anything. That's the amazing thing that happens in math. You can glue pieces back together. In math, we assume everything's homogeneous. Not so in the real world, but in math, you can just use cake glue. In math, you can just glue those things together. And that's how you should think about simplifying fractions. You shouldn't think about it as finding the greatest common factor. Notice I didn't use the greatest common factor here. The first thing I saw was that I could divide it into pairs, and then I saw that I could put those pairs into groups of 3s, and I got the same answer. The fast way to do it is only the best way to do it if it's really the fastest. Sometimes your teacher taught you a way to do something that isn't actually quicker because you forget it. Because if you don't remember how to find the greatest common factor, that's not very helpful. I don't use Euclid's algorithm to simplify giant fractions by finding the greatest common factor. I say, well, they're both even, so let's divide them both by 2. I start small and just keep going until I run out of primes to divide by, or run out of composites to divide by. You don't know my life. I can divide by whatever the hell I want. Alright, so there is my diatribe on simplifying fractions. I hope you enjoyed it. I think it would be fun to do some more fraction stuff another time, so maybe I'll record a 4th video There is some more jazzing up this outfit left to do also because it's kind of warm down here and I don't know if I need this shirt.